Okay, so hello everyone. Welcome to another interesting session of the Astro Club. So today we're going to discuss a very interesting topic. But before we get into the topic, I would like to ask one question to you all. Have you ever been to a laser show or a light show? Any one of you, have you ever been to a laser show or a light show?
No.
No, okay, fine. But do you know how it looks? The lights all they come in different colors and
Yes.
different shapes. Do you have idea about it? Yeah, okay. So those are all the man-made light shows and laser shows. But just imagine how it would look like or how it would feel if the same laser show or the light show is given to us by the nature in the sky. Just imagine how it looks. It looks very spectacular and very mesmerizing, right? Is it right?
Yeah.
Yeah.
Yes, sir.
So today our topic is the natural light shows or laser shows. So that is auroras. So today we are going to discuss about auroras and it's a very interesting topic. Okay, so let's see. So first of all, let's see what an aurora is. Is my screen visible?
Yes, sir.
Yes, yeah. Yeah. So first, let's see. Yeah. Okay. So first, let's see what is an aurora. So if you're ever near the North Pole or the South Pole, you may be in a special treat. So North Pole, in the sense, the North Pole countries like Canada, Greenland, Russia, etc. And the South Pole, in the sense, the South Pole countries like Australia, France, New Zealand, UK, like that. So if you're ever near the North Pole or the South Pole, you may be in a special treat. So frequently, there are beautiful light shows in the sky. So you can see many light shows frequently. There are beautiful light shows in the sky. Okay, so these lights are called as auroras. The natural light shows in the sky are called as auroras. So these lights are of red, green, and purplish blue in color. So they can be in any color, red, green, or purplish blue in color. So see this picture here. Okay, someone is joining. Let me admit them. Okay, so see this picture here. This beautiful view of aurora was taken from the International Space Station as it crossed over the southern Indian Ocean on September 17, 2011. Okay, so this is one beautiful picture of one of the auroras. Okay, next. So if you are near the North Pole, it is called as Aurora Borealis or the Northern Lights. Okay, so the Northern Lights are called as Aurora Borealis in the North Pole. So see this picture here. Aurora Borealis overhead the fisherman village. So this is the fisherman village of rainy Norway, Nordland country, Lofoten Island. So in Norway, in the fisherman village of Norway, in the sky here, the Aurora Borealis have appeared here. Okay, Aurora Borealis means nothing but the northern lights. Okay, are you able to understand this?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. Next. Now let's go to the southern lights. So if you are near the South Pole, it is called as Aurora Australis. Okay, Aurora Australis or the southern lights. Aurora Borealis means northern lights. Aurora Australis means southern lights. Okay, see here. Aurora Australis seen over Lake Dunstan, New Zealand. So New Zealand is located near the South Pole. So there above in the sky, this Aurora Australis has appeared. Okay, so we can say that Aurora Australis is the southern cousin to the northern lights. So these both are just like the cousins. We can just compare it in that way. Okay, so now the word aurora is derived from the name of the Roman goddess of the dawn. So she is the Roman goddess of the dawn. Her name is Aurora. So this word aurora is also derived from her name. Okay, did you all understand?
Yes, sir. Yes, Akka.
Yeah. So next. So auroras take many shapes and forms, with arcs and rays of colored light most common. So they take many shapes and forms. So the light may also look like shimmering curtains, bands, waves, or clouds. It can be of any shape. Okay, an aurora constantly changes the shape as the light moves across the sky. So the aurora, it doesn't stay in one particular shape. As the light moves across the sky, the shape of the aurora also changes. So this light also may brighten and fade. The light also sometimes it becomes brightened and sometimes it fades. So observe these pictures here. Images of auroras from around the world, including those with rarer red and blue lights. So see here, they have different colors, red, blue, and green. Here, pink also. And they're of different shapes. Okay. Is it clear?
Yes, Akka.
Yeah.
Yes.
Yeah. So even though auroras are best seen at night, they are actually caused by the sun. So we can see auroras only during the night time. Auroras are present during the daytime also, but we can't observe them. Why? Because of the light of the sun. We can't observe them during the daytime. We can observe them only during the night time. But how are the auroras formed? The auroras are actually formed by the sun. See here in this slide, the sun is saying, yeah, it's all because of me. So auroras are formed mainly because of the sun. So the sun senses heat and light. We know that the sun senses heat and light. So apart from heat and light, it also senses lots of other energy and small particles our way. Sun doesn't send only heat and light. It sends energy and it sends some small particles also. So the protective magnetic field around the earth shields us from most of the energy and particles, and we don't even notice them. So around the earth, we have a protective magnetic field. So this protective magnetic field, it protects the earth from all these particles and all the other energy. Okay, so we don't even notice them. But actually, there's a lot of energy coming from the sun. And our earth is protected from all of those energy and particles due to this protective magnetic field. Did you all understand?
Yes, Akka. Anytime. Yes.
Yeah. Next. So, but the sun doesn't send us the same amount of energy all the time. In the previous slide, I said that sun senses energy, but it does not send the same amount of energy. Okay, sometimes it sends large amount of energy, sometimes it sends less amount of energy, like that. And there is a constant streaming of solar wind and also the solar storms. So sometimes it also uses in the form of the solar wind and solar storms. We also experience these from the sun. Okay. So during one kind of solar storm, there was a kind of ejection. During one solar storm, there was a kind of ejection. So we call that ejection as the coronal mass ejection, or CME. Okay, this is a coronal mass ejection, which is a kind of solar storm. Okay, so the sun burps out. We know the burp, right? What a burp is. So the sun burps out huge bubbles of electrified gas. The sun burps out a huge amount of electrified gas that can travel through space at high speeds. Okay, did you all understand?
Yes, Akka.
Yeah.
Yes, sir.
Yeah. So observe this picture very carefully. So when a solar storm comes towards us, so see this is the sun and this is solar wind or the solar storm, we can call it as. So when the solar storm comes towards us, some of the energy and the small particles can travel down the magnetic field lines. See, these violet color lines are the magnetic field lines. So these yellow color lines are the solar wind or the solar storms. So observe this. These solar storms are traveling down the magnetic field lines. They are going like towards the magnetic field lines and all. And finally, they end at the North Pole or the South Pole. See here, the North Pole or South Pole. All of these solar storms are finally ending up at the North Pole or South Pole. Okay, there means in the North Pole or South Pole, there these particles or the solar storms they interact with the gases in the atmosphere, resulting in beautiful displays of light in the sky. So this is how auroras are formed. So when these solar storms and all of the particles from the sun, when they converge in the North Pole or South Pole, they react with the particles or they react with the atoms present in the atmosphere, and they form as spectacular colors of light in the sky. Okay, did you all understand?
Yes, Akka.
Yeah. So see. Okay, so oxygen gives off the green and red light, and nitrogen glows as blue and purple. We have the gases in the atmosphere, right? Oxygen, nitrogen, and all. So oxygen gives out the green and red light, and nitrogen glows as blue and purple. See, observe this image here. The green bands of light in the sky are an Aurora Australis, an aurora at the South Pole. So see, in one of the place, this aurora was formed. It's in the green color, green bands of light. Okay, so now we are going to witness some of the spectacular pictures of auroras that were formed across the globe. So see, observe this, how amazing they are. Okay, these are all the real pictures that were taken. Wow, see how beautiful they are.
Yes, Akka, with different colors.
Yeah, with different colors and different shapes. Nothing can match these auroras. These are the natural laser shows in the sky. Okay, we have observed, or we may have observed the man-made laser shows and all, but we have never seen these natural auroras. Okay, yeah. Next. So, do other planets get auroras? We have talked about Earth. What about other planets? Yes, they sure do. Auroras are not just something that happen on Earth. So if a planet has atmosphere and magnetic field, they probably have auroras. So for auroras to form, there are two conditions. The planet should have an atmosphere. Yes, second, someone is joining. Okay, so the planet should have an atmosphere and it should have a magnetic field. If these two conditions are satisfied by a planet, then they definitely have auroras. So in this picture, you can see the amazing auroras in Jupiter and Saturn. This first picture, the NASA Hubble Space Telescope took this picture of aurora on Jupiter using ultraviolet light. And the next picture, these swirls of red light are an aurora on the South Pole, see, of Saturn. Okay, did you all understand? So auroras are not formed just only on Earth. They are formed on other planets as well. For example, see here, the Jupiter and Saturn. Okay, so did you all understand about auroras?
Yes, Akka.
Yeah. So now we have a couple of videos to watch. Let's watch those videos so that you can better understand.
Yes, Akka.
About auroras. So let me share my screen.
The Cree called them the dance of the spirits. In Finland, they said,
Is it visible and audible?
Yes, Akka.
Yeah, okay.
Yes, Akka.
caused by the firefox running so quickly across the snow that his tail sent sparks into the sky. Ancient Chinese observers believed they were the flames of good and evil dragons battling in the heavens. Even today, these mysterious and unpredictable lights are called aurora, after the Roman goddess of the dawn. An aurora, also known as a polar light, is a display of lights in the sky in the Arctic and Antarctic regions, in an area known as the auroral zone. An aurora around the North Pole is called Aurora Borealis, or the Northern Lights. An aurora around the South Pole is called Aurora Australis, or the Southern Lights. They are usually greenish in color, but are sometimes blue, violet, pink, or even red. Auroras constantly move and change shape. Sometimes they are so dim they can be mistaken for clouds. Other times they are bright enough to read by. But what causes these amazing lights? Auroras actually begin at the sun, which burns with so much energy that it superheats the gases around it. Tiny particles, or pieces of the sun, are blasted away from it at speeds of over 450 miles, or 750 kilometers per second. This stream of particles is called the solar wind, and the Earth is directly in its path. The solar wind can disrupt satellites and be harmful to astronauts in space. But the Earth is protected because of its magnetic field. The Earth has a molten iron core that rotates quickly, turning it into a giant magnet. The magnetic field around the Earth is called the Magnetosphere, and like a magnet, it has a North Pole and a South Pole. Most of the particles from the Sun are deflected by the Earth's magnetosphere, but some make it through to bombard the atmosphere. As these electrically charged particles strike the atmosphere, they excite the oxygen and nitrogen atoms, causing them to light up in the beautiful colors of an aurora. If you want to see an aurora on Earth, you should head to areas near the poles. You may not know that auroras are also visible from space, where they can be seen as rings around the North and South poles. The Earth is not the only planet to have auroras. They have been observed on Mars, Jupiter, Saturn, Neptune, and Uranus as well. Like the auroras on Earth, auroras on other planets occur around their north and south poles. Shifting curtains of light in the night sky. Auroras have fascinated people for thousands of years. They are a visible reminder of the connection our Earth has to the Sun, and one of the most beautiful phenomena in the heavens. I hope you enjoyed learning about auroras today. Goodbye till next time.
So did you all understand about auroras?
Yes, Akka.
Yeah. So there is one interesting fact about auroras. There's a particular type of aurora called as blood aurora. Blood aurora, in the sense the color of the aurora is in deep red in color, just like our blood. Okay, so this aurora is observed once in every 10 years. Okay, this aurora is observed once in every 10 years. And recently in 2020, that is last year, in US, in United States of America, in Georgia state, before the US elections. So last year, US conducted its elections, right? So before the US elections, the people in Georgia have observed the blood aurora in the sky. So the sky was completely deep red in color, and it was really a spectacular sight. So that is one interesting fact about aurora. And another interesting fact is that we can see auroras for every 2 hours. So there is no particular time when the auroras can be seen. Every 2 hours, auroras keep on forming. Okay, even during the daytime also auroras are there, but we can't see them due to the light of the sun. But during the night time, people in the northern countries, North Pole countries and South Pole countries can see them very clearly. Okay, did you all understand?
Yes, sir.
Yeah, so we have one more video, the last video. It's just a short video, so we'll watch that also.
Okay.
Yeah.
Topic: auroras.
Huh?
Why are auroras formed?
Maybe because the Earth forgets to switch off the lights.
Nah.
Huh?
Let me explain. Our sun is a giant burning star. It expels tons of solar wind into space. Solar
Huh?
wind consists of super hot charged particles, which are fatal.
So should we use a big umbrella to protect ourselves from these particles?
No.
Huh?
The Earth's magnetic field acts like a shield and protects us. Its field lines appear to emerge from the South Pole and merge into the North Pole. Now, when the charged particles hit our magnetic field, most of them get deflected. However, some
Huh?
of them flow along the Earth's magnetic field lines to the poles and reach our upper atmosphere. Here, these particles collide with oxygen and nitrogen. This causes them to give off various colors of light, which are called auroras.
Okay, so that is just a short video on how auroras are formed. Okay, is it clear to everyone?
Yes, sir.
Yeah. Okay, so if you have no doubts, then I think we can wind up the session. Do you have any doubts?
No, Akka.
No doubts? Okay then.
No.
Yeah. Okay then.
Akka,
Yeah.
will you send this video in the WhatsApp and in YouTube?
Yeah, I'll upload it. Maybe tomorrow, I
Okay.
guess. I'll do it.
Okay, Akka.
Yeah. Okay, so that's the end of the session. You can all leave. Thank you.